Hello, everyone. Welcome to the Math Magician's Den. We're going to do some more problems that involve the derivative of the natural log. We're going to make it a little more complicated here in this video. You'll notice this first problem, it involves functions that are a little bit more complicated than just a product rule or a quotient rule or a chain rule. It has multiple rules involved. Here, we need to find the derivative of y with respect to t. Well, how would I do that? Well, this involves two functions that are multiplied together, so I'm at least going to have to do a product rule. The derivative of the first part, the derivative of t, would be 1 times the natural log of 2t squared, plus the first function, which is t, and we're going to multiply that by the derivative of the second function, which involves a power rule and a chain rule. We're going to bring that 2 out front. The natural log of 2t is now going to be raised to the first. But what is the derivative of the natural log of 2t? Well, if you watch one of my previous videos about natural logs, that's just going to be 1 over t. So my derivative here is going to be the natural log squared of 2t plus, over here you're going to notice the t's cancel. And I'm going to be left with 2 natural log of 2t. Okay? Now, these two functions are not the same, or these two terms are not the same. This one, the natural log, is squared. If I put this 2 back in here, the natural log isn't squared, the 2t is squared. So this one here is the natural log squared of 2t, whereas this one is the natural log of really 4t squared. So there's my derivative. And honestly, this spot right here would have been fine too, but just showing you those are not like terms in that particular question. Now we're going to do this again. This next problem also involves a product rule and a chain rule, but they're in a different order. If I take the derivative of y with respect to x, dy dx, I would have to bring that 4 out front. Now my x squared natural log of x would have to be raised to the third power. That's the power rule. But what's the derivative of the inside function? I'm going to have to do a product rule. The derivative of the first function right here would be 2x times the second function, the natural log of x. Product rule is plus. And then it would be x squared times the derivative of the natural log, which would be 1 over x. There's not much here I can do to simplify. This is going to be 4 times x squared natural log of x to the third. And in the parentheses here, I'd have 2x natural log of x plus x. And like I said, really, how much more can we do there to simplify? I think if we're taking a test, this derivative would be just fine. Now, I could do some simplifying here. This would be 4x to the 6 natural log cubed of x. And then if I distribute, it gets really ugly here. Well, a little bit less ugly, I guess. It would be 8x to the 7th natural log to the 4th x. And then it would be plus 4x to the 7th natural log cubed of x. If I didn't want any parentheses, that's my answer right there. So you notice these problems are getting a little bit more difficult as we move along. Now, I don't know if I'd consider this next problem difficult, but it definitely involves a rule. Other than just something simple, this involves a quotient rule. If I'm going to take the derivative of y with respect to x, I have to take the derivative of the top, which is 1 over x, times the bottom. This time it's minus the top, which is the natural log of x, times the derivative of the bottom. And the derivative of the bottom would be 0 plus 1 over x. And this would be all over 2 plus the natural log of x squared. Now, I've always told my students I don't like fractions within fractions. So what I'm going to do here is I'm going to multiply the top by x, and I'm going to multiply the bottom by x. If I distribute that x here, they're going to cancel. It's going to give me 2 plus the natural log of x. If I distribute here, it's going to give me minus natural log of x. And the bottom would be x times that quantity, 2 plus natural log of x squared. And you notice I can simplify even further. Those natural log of x's cancel. And I get 2 over x times 2 plus natural log of x quantity squared. There is my derivative. So we're going to keep going here. And when you get to this problem, you're thinking, wow, if I'm going to, first of all, this doesn't have any natural logarithms. Why do I have it in this video? Well, first of all, I have it in this video for a specific reason. We're going to use natural logarithms. This problem involves a power rule. It involves a fractional exponent on the bottom. It involves a quotient rule, a chain rule. This would get ugly if I tried to do this all as just a normal problem. But what we're going to do, we're going to do something that's called logarithmic differentiation. I'm going to take the natural log of both sides. So on the left-hand side, I'm going to write the natural log of y. On the other side, if I take the natural log, it would be the natural log of x minus 2, and I can expand. I can bring that 2 out front. And then it would be minus the natural log of the x squared plus 1, and on that one, since it's raised to the 1/2, I can bring the 1/2 out front. This is not the derivative. What I've done here is I've expanded the right-hand side so the derivatives are going to be easier to do. Now, I've got to be careful about the left-hand side. What's the derivative of the natural log of y? Well, if you guys remember, the derivative of the natural log of u with respect to x was u prime over u. So here, wouldn't the derivative of the natural log of y be y prime over y? And then I'd have 2 times 1 over x minus 2 minus 1/2 times 2x over x squared plus 1. I'm just using our rules for logarithms. So on this side over here, I'd have 2 over x minus 2. In the second fraction, these 2's would cancel. I get x over x squared plus 1. But I'm really trying to find out what y prime is. So what I'm going to have to do is I'm going to have to multiply by y on both sides. If I multiply by y, right here I'd have to multiply by y, which is x minus 2 squared over radical x squared plus 1. There is my final answer. And I, as a teacher, would not make you simplify that. I'm not going to make you distribute. I'm not going to make you try and make it one big fraction. When we're doing logarithmic differentiation, we're trying to make it easier just to find the derivative. So same thing on this bottom problem here, problem you see in the middle of the screen right now. We're going to take the natural log of both sides. So it's going to be the natural log of y equals the natural log of x plus 1/2 the natural log of x squared plus 1 minus 2/3 the natural log of x plus 3. And again, this is not a derivative. This is just expanding my original function. So what are my derivatives? The derivative of y with respect to x is y prime. So the derivative of the natural log of y would be y prime over y. The derivative of the natural log of x is 1 over x. And then use that rule I just showed you on the previous problem right here. Put the derivative of the function over the function itself. So this problem would have a 1/2 times 2x over x squared plus 1. And then it would be minus 2/3 times 1 over x plus 3. So if you're looking at the right-hand side, I've got a 1 over x plus x over x squared plus 1. And then I've got minus 2, multiply the bottom by 3, I'd have 3x plus 9. And guess what I'm going to have to do again to solve for y prime? Well, to solve for y prime, I've got to multiply the y to the other side. And what's y? Y is x radical x squared plus 1 all over x plus 3 to the 2/3. So you notice logarithms can be very, very useful. And when I say logarithms, in calculus, I mean natural logarithms. Okay, natural logarithms have a very simple derivative. It is just 1 over x. We're going to do one more problem in this video here, and I always present this to my kids, and I tell them, what are you going to do? You can't use a power rule here because there are variables in the exponent. You can't use an exponent rule here because there are variables in the base. So what do? We're going to do exactly what we were just doing. We're going to take the natural log of both sides. We're going to take the natural log of x to the 7y equals the natural log of y to the 3x. Now this is going to get ugly. Why did I take the natural log? Because on this natural log of x, I could bring the 7y out front. And on the natural log of y, I can bring the 3x out front. Now, I have not taken a derivative yet here, but I have simply made it easier. It is not an exponential function anymore. This is both product rules. Now, the product rule here, I'm going to take the derivative of 7y, which is 7y prime, times the natural log of x, and then plus 7y times the derivative of the natural log of x, which is 1 over x. On the other side, the derivative of 3x is 3 times the natural log of y, plus 3x times the derivative of the natural log of y, which would be y prime over y. That is our derivative. Now, we're trying to find the derivative of y with respect to x. What is that? That's the y prime we have in the problem there. Now, the first thing I don't like the fact that there's fractions. I don't like the fact that I have denominators. So what I'm going to do is I'm going to multiply every term by xy. If I multiply this by xy, I would get 7xy natural log of x, and that's going to be multiplied by my y prime. You guys are going to notice I'm going to put my y primes in a different color. If I distribute here, the x's will cancel and I get 7y squared. Distribute here, I would get 3xy natural log of y. Distribute here, I would get 3x squared. The y's would cancel, and I would get that 3x squared just times y prime. Now, we've done implicit differentiation, obviously, in another lesson, in another video. So what am I going to do here to solve for y prime? Well, I've got to get the y prime terms on the same side. So what I'm going to do here, I'm going to put this one over here, 7xy natural log of x times y prime. And this term, I'm going to move over here. I'm going to subtract that 3x squared y prime. On the other side, I've still got the 3xy natural log of y. But this 7y squared, I'm going to subtract that to the other side. Now you'll notice on the left-hand side, if I factor out the y prime, okay, on the other side, I still have the 3xy natural log of y minus 7y squared. But over here, this is what would be left if you factored out the y prime. So that is what you're going to end up dividing by. You're going to end up dividing by 7xy natural log of x minus 3x squared. And ladies and gentlemen, there's your derivative. Hope you enjoyed the video. If you did, please hit the like button and subscribe. I appreciate it. I hope these videos are helping you for your class. I'll be posting more later.